one. It was 3y plus 4, 3y plus 4. By the way, what's another way of writing that? 3y plus 4 squared. Okay? Bobby? 9y squared, you meant?
Yeah.
Plus 24y plus 16. Because when you're multiplying this out, you get a 12y and a 12y. You get two middle terms exactly the same. Number 4, 6x plus 7 squared. Again, that's the same as this. What did we get? 36x squared. Good. 42x and 42x is plus 84x plus 49. Number 2. I guess I should go in order, huh? 2x minus 5 squared means 2x minus 5. 2x minus 5. 4x squared minus 20x plus 25. In these special cases, there's exactly two middle terms that are the same, and you can get them by multiplying these together. Because you get 6 times 7, 7 times 6. So 42x and 42x is 84x. Here, 3 times 4 is 12. 12 times 2 is 24. 2 times negative 5 is negative 10. But we're going to have two. That's the shortcut. I'm going to have two of them because I have minus 10x, so I get minus 20x. So now, in 3, what 7 times negative 1? It's negative 7. Double it. Negative 14. So this is going to be 49m squared. Negative 7m, so negative 14m. And what's negative 1 squared? Plus 1. Okay, what happens in 5? The middle terms cancel. So what do we have? Okay, these are going to be pretty obvious because there's only, thank you, sorry. There's only 2 terms, whereas these ones were 3. Same thing here, right? What did we get for this one? Very nice. And we call these a difference of squares, okay? So now we're going to just go back and see what the patterns are with these things. Couple things I want to point out to you. First of all, on these ones, there's just 2 numbers, and 25 and 81 are things that we call perfect squares. We had those, remember, root cards before? Okay, what's the square root of 25? And what's the square root of 81? 9. They're perfect squares. How about square root of 64? And the square root of 49? And notice 8 and 7. Okay. Now, the other ones are similar because they still, for instance, this is a 9 and this is a 16. What's the square root of 9? 3. And what's the square root of 16? 4. But these have a middle term. And that middle term is 3 times 4 doubled. 3 times 4 doubled. Okay? So the first ones are called perfect square trinomials. Perfect squares. Trinomial, why is it called a trinomial? How many terms do they have? 3. Okay, so perfect square trinomials looks like this. If you have a perfect square on the front, and you have 2 identical terms to make up the middle term, and then you have a perfect square on the back, that's called a perfect square trinomial. And we factor, here's a picture of it, an area picture. We factor it, because look at this, a squared, look at there's an AB and an AB. That's 2 ABs. Okay. Notice, this is a square. That means its length and width are exactly the same. So, this factors into A plus B, or A plus B squared. Okay. Now, the other case is this. Very similar. What if I have A squared minus 2AB plus B squared? Still a perfect square and a perfect square, but this is a minus 2AB. what does that factor into? Instead of a plus b parentheses squared, a minus b parentheses squared. For instance, look at number 2 up here, okay? 2x minus 5 squared, this was still positive, this was still positive, but the middle term was negative because there were 2 of the negative 10x terms. Okay, I don't know if you can figure out the area of this piece. Basically what I'm doing here is I'm taking a squared and subtracting b squared, okay? And the way that I do a squared, if I would take out that b squared and rearrange the pieces, I would get this rectangle here. I'll show you in a second. So a squared minus b squared factors into a plus b, a minus b. Okay. So, do you see how this is a and this is a? I'm going to explain this picture for you. This whole piece is a and this whole piece is a, correct? Okay. If I would take out this little square, wouldn't the area of this be a squared minus b squared? Big rectangle minus little rectangle. Okay. Okay, so if I took this piece out, there would be a little hole here, right? Let's say I cut on this line and I put that little piece down over here. So I have a rectangle. What I just did is I took off b from here, but added b to here. So this side is a minus b, this side is a plus b. So, is that a big deal if you don't understand that? No, but that's really what happens with the area. If I take off this piece, what I do is I cut off this little rectangle and I take a little piece of b off of this edge and then I add it to that. So this is a minus b because I took it off, and then I added it onto the bottom, so this is a plus b on the bottom. Alright, let's do our 6 examples. So first of all, right off the bat, which ones are differences of squares without hardly having to look very far? Which ones can you tell? I know they're not numbers, but gives me the problem. Caitlin? Yeah, and what else? So let's do those ones. Those are differences of perfect squares. And when we factor them, to get the a plus b, a minus b, we take the square root of these things. What is the square root of 81x squared? 9x. What's the square root of 64? 8. So this is going to factor into 9x plus 8, 9x minus 8. What if you wrote 9x minus 8, 9x plus 8? Doesn't matter. As long as one is plus, one is minus. What if I put a variable after it? What's this? Then just add the variable in. What's the square root of 49x squared? 7x. What's the square root of 16y squared? 4y. So it's going to be 7x minus 4y, 7x plus 4y. Let's say you're a little bit shaky and you're like, crap, I can't remember which one this is. You could still do the outers and inners to check and make sure you have it right. Alright, the remaining 4 are perfect square trinomials. Can anybody, let's look. What's the square root of x squared? Square root of x squared. What's the square root of 1? 1. And they're all addition, right? Can somebody tell me what this factors into? Caitlin? X plus 1 times x plus 1 or x plus 1 squared. And then we always want to check the middle term. X times 1 is x, right? Multiply it by 2, we get 2x. Okay, let's check this one. What's the square root of 9x squared? 3x. What's the square root of 64? 8. What's 3x times 8? What's 3x times 8? 24. Double it, isn't that 48? Just double checking that that middle term works. Is this a plus or a minus sign?
Minus.
3x minus 8 parentheses squared. Because think about that. You'd have minus 24x, minus 24x, but what is negative 8 times negative 8? A positive 64. Does anybody want to try the next one? They think they got it. Cody? Very nice. So the square root of 4n squared is 2n. Square root of 25 is 5. 2n times negative 5 is negative 10. Doubled is negative 20. All right. Any takers for the last one? Caitlin? 9z plus 2 parentheses squared. Okay. What's the worst case scenario? The worst case scenario, if you don't recognize these, is you start to do factoring. And then guess what? You would get x plus 1 and x plus 1. It's not the end of the world. It just took you maybe a little longer to recognize. Or what if you started and you did the long factoring and you got 2n minus 5 and 2n minus 5? Again, it's not the end of the world. But if you start to notice perfect squares, then maybe it will make your life a little easier because it's one of those special cases. So that's really the point of the lesson today. It's not that you can't factor these the way that we were factoring before. It's just that hopefully I was looking for some patterns that you would notice. All right, so let's do some special cases on your whiteboard.